Hello everybody, this is Gigi from Kauai Community College. In this video, the third of the 3-video series on functions and graphs, we will be talking about how to find a domain of a function algebraically. Okay, so given an equation, say f of x is equal to 8x divided by x squared minus 4. So x being the input and the f of x being the output here, right? The question is asking, find a domain algebraically, meaning use algebra to find a domain. Now, when looking at this function, we read that as a times x and then all divided by x squared minus 4. We got to pay attention to the operations that are being done to x. Multiplying by 8 can always happen. You can always take a number and multiply by 8, so there's no restrictions there. But when we are trying to divide that quantity of 8x by x squared minus 4, we are going to run into trouble if x squared minus 4, the denominator, is 0, because we know we cannot divide by 0, right? That will give you an undefined answer. So the domain of f of x would be basically we can take any x except for, in this case, when the denominator is 0. We cannot do that, right? So denominator cannot be 0. Well, let's go and actually find out, when is x squared minus 4 0? When x is 2 or negative 2. So the domain is anything except for 2 and negative 2. How does that look on a number graph? Well, 2, negative 2, you are not it. So we're going to put open circle in both places, and we will take anything else except for 2 and negative 2. So we will use interval notation here to write the domain of f of x, which would be negative infinity to negative 2, union negative 2 to 2, open, right? Because we're not including those endpoints, and union 2 to infinity. So what does that mean to the graph of this function f of x, given that being its domain? Well, it will have 3 pieces. Right? The graph, however it looks like, it has 3 different pieces, and there is nothing at negative 2, and there's nothing, no order pair at negative 2, no order pair at positive 2. Make sense? All right, next problem. Find a domain of this function g of t, right? That means t is your input and g of t is your output. And since we're looking for the domain, we're looking for the restrictions really on the t value. So what is being done to t, the input? Multiply by 1/2, which you can always do, right? And subtract that from 9. And then taking the absolute value of negative 8t. You can always do that. You can always multiply a number by negative 8 and then take its absolute value. So there is no restriction on the input t based on the operations that are given in this function. So the domain is anything on the number line, meaning negative infinity to positive infinity. So we will have, however this graph look like, a continuous curve, right? There's no breaks as you have seen in the previous problem. All right, finding the domain of h of x being 3 times x plus square root of 5 minus x plus 9. So x is being the input here, right? So we're gonna take x and then times it by 3, which we can always do. So that's not an issue. And then we'll take 5 minus that x, which can always happen. You'll get positive, negative answers, or 0 if x is 5. But because we do have to take the square root of 5 minus x. 5 minus x will have to be 0 or higher to have a real value output. So there is restriction on that x value, okay? And then you can always add 9. So there's no further restriction. There's only one, and that would be 5 minus x will have to be greater than or equal to 0. This is just a basic linear inequality to solve for, so x would have to be less than or equal to 5. On a number graph, it will look like this. 5 is your cutoff point, and you'll take anything equal to 5 or less than. So then the domain would be negative infinity to 5, open on the left, but closed on the right. So when looking at the graph of this function, we don't yet know how it looks like, but we do know that the graph will lie on the left of 5 and there is nothing to the right of 5. Okay, and that's what the domain tells you in terms of graphing, where the graph would be if you consider your x-axis as your number graph here. All right, finding the domain of this function. So let's stare at this here. What do we see? We see a square root, right? So the thing under the square root would have to be 0 or higher in order for it to have a real value answer. And then the denominator cannot be 0. So you have two restrictions. One is x has to be greater than or equal to 0. So imagine your number graph. The domain would have to be at right now at this point to the right of 0, right? And it also have to exclude the points where the x value where x squared plus 8x minus 9 is 0. So when does that happen? X squared plus 8x minus 9 can be factored out to be x plus 9x minus 2. So x is negative 9 or 1. So we have to go and exclude those points there, right? So the domain is greater than 0 and must also exclude negative 9 and 1. Let's put on your number graph. Those are your cutoff points. We would say, oh, nothing to the left. We will take 0 because that's okay, greater than or equal to 0. But we will not take 1. So we do have a break on our interval. We will use union, right? From 0 to 1, union 1 to infinity. So pay attention to the bracket and the parentheses there. So the graph would be, the graph of a of x here would be to the right of 0, and it has two different pieces to it. And that is how we find the domain algebraically. And that wraps up your lesson on functions and graphs. Your first lesson in Math 103. That is it.